and that's what healthy soil looks like. But what happens is we come with a plow and we mix that all up. And it then looks pretty much like this, where now there's no distinction between the aggregates. All the sand, silt and clay has been mixed up. You can't see the humic acid or the humus. It's all been often washed out of the soil, so we're losing nutrition, we've lost space, and what we have done is we've actually made a compacted soil. If any of you have made bricks for building your houses, think about the process of what it takes to make a brick. We've got very good soil, preferably with a higher clay content, and we add water to that and we mix it up together. And once it's well mixed, we then put it into the sun to dry, and we know that those bricks that we put there, even without any burning, are going to become very, very hard, and we can build a house with them. So how is that process any different to the plowing that we do? We've got our field, it's got very good, hopefully clay content. God brings the rain as the water, and then we come with our plow, we mix it all up, and then we leave it in the sun to dry. In reality, it's exactly the same process as what we do to make bricks. Yet when we plow, we're thinking that we should be making the soil softer. But in reality, if we think about it, it's the same as making bricks, and we're actually making the soil harder. And it's the same as when you're making your ridges. You're moving the soil, you're mixing it up, and you're turning it. Often you would probably do that when the soil is still dry, but the process is still the same. How do we redeem the soil from this state? If we have disturbed the soil, we've plowed it for many years, or we've been making ridges for many years, you might be thinking to yourself, oh dear, I've done a terrible thing. How can I fix this? Please God, will you forgive me? Fortunately, we have a very, very loving, forgiving God, and He has given us the ability to redeem this. And it doesn't take a very long time. In fact, in a few years, we can get back to a healthy soil as long as we start following God's way. The first thing we need to do is to stop disturbing the soil. No more plowing, no more ridging. Leave the soil alone, do not touch it, allow it to start creating structure again. The second thing we need to do is to cover the soil with a mulch. So in this picture we've got the roots of a plant. Let's say it's a maize plant, and on the top of the soil we have got mulch cover. You can see the soil is still the plowed soil, there's no structure in there, all the particles are very close together. The third thing that we would need to do, which is the third rule of conservation agriculture, is that we would need to do crop rotation. So that's the next process that we would do. But before we go there, I want to ask you a question. If this plant, this root of this maize, is undisturbed because we don't plow, and the maize is harvested, the stalks are laid down as mulch, what happens to the root in that soil? I'm sure you understand that in a very short space of time, that root is going to decompose, or it's going to be eaten by some insects. And what happens is, where that root was, there is now empty channels into the soil. The root is gone, but those channels remain. And those channels now are a place where water can get easily into the soil. Once we start doing crop rotation, so the next year we plant a different crop, any kind of beans, and you'll see the root system is slightly different. And again, at the end of that season, we harvest the beans, but we do not disturb the soil. What happens to the root of that plant? It too will decompose and leave channels in the soil. And you can start to see that now we're slowly building some structure back in the soil. Water can get down into those channels, and if we look at this picture now and go back to the original one that we saw, you'll see it's very much like the structured soil that we had to begin with. So we can redeem our soil from compaction by doing those three simple things. That is, no more soil disturbance, cover our soil with a blanket, and do crop rotation. And in a very short space of time, of 2 or 3 years, you're starting to see soil structure developed again. Right, the next thing that I'd like to speak about is pH in our soil. For those of you who don't understand what pH is, it is the measure of acid in our soils. Some of you might understand that there's already a scale, and if you say that the pH of my soil is 7, that means it is neutral. And most plants like to grow in a neutral soil from about 6.5 up to 7. That is where most of your nutrients are very available in the soil and where a plant is most happy. Now, if I ask you a question of what is the difference in acidity, how much more acid is a soil that is 7 and 6? 6 is obviously more acid, but how many more times acid is it? It's one point difference on the scale from 6 to 7. Now, in reality, or the way that they measure it, it is they call it a 10 times iron concentration change in 1 point change. 10 times iron concentration. That means that there's 10 times more acid in the soil at 6 than there is at 7. So if I say, what is the difference between 7 and 5? Most of you in Malawi will have soils of 5, if not less than 5. What is it? How much more acid or too acid is it? From 7 to 6, it's 10 times. And then again from 6 to 5, it's another 10 times. So from 7 to 5 is actually 10 multiplied by 10 is 100 times. So when you say you've got a pH of 5, it means your soil is 100 times too acidic. Some of you might find that you've got soils that are close to 4 pH. That means they are 10 times 10 times 10. That is 1,000 times too acidic for what your plant likes. Too much acid. And unfortunately in Africa, most of us don't understand the effect of adding nitrates and other types of fertilizers to our soils. And what happens when we do that is those fertilizers react in the soil, mainly with water, and the hydrogen from the water combines to, for example, the nitrogen from ammonium nitrate, and it creates nitric acid in the soil. Nitric acid is a very strong acid, and it's going to make our soils more acid. What we need to understand is that when our soils become acid, the other nutrients in the soil, like phosphorus for example, become locked up. It means that they are no longer available to the plants, even though the phosphate is still there in the soil, and you could be applying phosphate fertilizer every single year. But because your pH is below 6, then it will be locked up. If you look at this picture, this is a graph that is showing where different elements are locked up. Along the top there is the scale from 5 on the left to 9 on the right. The first bar that you see across there is showing nitrogen. You can see it's fairly thick all the way across. Where it is a little bit thinner, so above where it is less than 6, so on the two columns to the left, you can see it starts to narrow a little bit. That means that nitrogen stops being as available than what it should be when your pH is less than 6. If you look at the second one, that is for phosphorus. And you can see at 6, when you get less than 6, it is much thinner. It's a very narrow band in that case. And that means phosphates are very much locked up, much more so than nitrogen, when your pH is less than 6. And I can guarantee every single one of you as farmers have got soils that are less than 6, and one of the reasons that your crops don't grow as well as they should do is because you have this acidic problem in your soil and your nutrients are locked up. They are there in the soil, but they are not available to your plants. So how do we fix this? It's a very, very simple thing. We just need to add lime to our soils. If we are able to add lime to our soils every single time that we add fertilizer, this problem will be alleviated. It will neutralize the acid in the soil. Lime is made up of calcium carbonate, and you can see a formula here of how calcium carbonate with hydrogen ions neutralizes the soil. So it takes the hydrogen ions away from the acid and it turns it back into carbon dioxide and water and neutralizes the acidity in the soil. So it's a very simple process, but unless we are adding lime to our soil, that's not going to happen. So you don't have to worry about the chemical formulas. All you need to do is trust that this is the right thing to do. Make sure you can find lime. I know in many places in Africa it is not an easy input to find, and that is crazy because it is actually the most important input. I challenge you to do a test on your fields. Instead of putting fertilizer on again this year, which you've probably done for the last 10 or maybe even more years, don't put any fertilizer on a piece, but put lime on that piece of land. And you will see that the fertilizers that you've been applying to that land over the last 10 years will suddenly be available to your plants. And you will see an incredible difference and increase in your yield just by applying lime to your soil. If we are going to do things on a more organic basis, meaning that we're not using fertilizers but we use compost instead, compost has the life in it, the biology that will allow the soil to not build up acidity. It is actually the best way that we should be farming, and that's the way that God intended us to farm. If you think about a big forest where there are big trees all growing naturally, where does the nutrients come from for those trees to grow? Is there a little person that has to go around into that forest every day putting fertilizer on those trees? No. But you all know that that soil is very fertile. And in many countries, people go to those forests, cut the trees down, and they plant their crops there because they know the soil is very fertile. And within a couple of years of using that land, they start to see that their crops are less and less productive. And then they'll go and find another place to cut the trees down. Now imagine if we could get that magic machine that makes the fertilizer for those big trees to be in our fields, to actually put that machine back in our fields so that our fields are becoming more and more fertile every year and not less and less fertile the way that they seem to do in our normal agricultural processes. Now this is something that is actually possible. By making compost, compost is full of living organisms. It's bacteria and fungi and their job is to create nutrients. And the way that they do that is they do many different functions. Some of them actually are able to take nutrients out of sand and rocks. Some of them decompose other organic material. Some of them just eat other ones. Doesn't matter what's happening in that system. What they do at the end of the day is create fertilizer in the soil through their dying, through their eating, through their making of manure. Then the plants are able to access that fertilizer, which is like microscopic manure, and it's in a form that the plants are able to choose what they want. The problem with fertilizers is that we prescribe what we think the plant should have. And in many ways, the salts that are the fertilizers act like a drug in the soil.